Alright, so as you can see, I have a friend today. Say hi, guys. She is super lovey, so we're going to do this while she sits on my lap until she decides to jump off. So today we're going to go ahead and talk about growth and decay of exponents. So we're going to use this growth function where a of t is equal to the total after some time. She's not letting me type. I'm getting kind of hurt my nose. Ah! Come on. There we go. A sub 0 is my initial amount. My R stands for rate as a decimal. And T stands for time. Typically in years, but it is dependent on the problem. So if the problem is in months, then the T will be in terms of months. If it's in seconds, it will be in seconds. So on and so forth. So we're going to suppose that the cost of a hamburger has been increasing at a rate of 9% per year. Then each year the cost is 1.09 times the cost of the previous year. Suppose that they now cost $4. Some projected future costs are given in the table below. Write an equation that represents the data. So we're going to go ahead and use that same formula that we just talked about before, the one that we just explained. So my amount is going to be after some time. In this case, it's going to be the amount it costs to purchase a hamburger. And that's my initial amount, so we're going to assume right now we're $4 because we want to see what happens in the future. And we're going to take that times 1.09, and there's several dots, so I'm going to erase that before I continue going. I only want one. I'm going to take that times 1.09. Oh, there she goes. All to the exponent of the t. I can't hear it in my nose. I need my calculator because I need to show you it. Okay, so there's my equation. Then, using the function above, find the cost of the hamburgers 5 years from now and 5 years ago. So first we're going to do 5 years from now. So because we're going in the future, my time is going to be increasing. So I have 4. Oops, that's not what I want to start with. Come on, eraser. There we go. So I have A of 5, because I'm doing 5 years from now, is equal to 4 times 1.09 to the 5. So in my calculator, I'm going to type 4. Oh, what did she push? Something just... nothing. Okay. I'm going to push 4, parentheses, 1.09, close parentheses, the caret key under the clear. That button. See how it goes up? Allows me to do the exponents of 5, and I'm going to hit enter. So in about 5 years, it's going to cost me $6 and about 15 cents. Because you've got the 4 after the 5, so it rounded down. What about 5 years ago? So my A is going to be, or excuse me, A of, well, if I want it 5 years in the past, time is going backwards, so I want it of -5. So that's 4 times 1.09 to the -5 this time. So same kind of idea. 4 parenthesis 1.09 close parenthesis the caret key -5. Make sure you guys can see it. And you're going to hit enter. And that gives me $2.60. So 5 years ago, a hamburger cost $2.60. In 5 years from now, it'll cost me $6.15. And that's because of inflation. Alright, let's take a look at another problem. Suppose that a radioactive isotope decays so that the radioactivity present decreases by 15% per day. If 40 kilograms are present now, find the amount present 6 days from now and 6 days ago. Well, first we need our equation. So I have A of T, so amount after some time. Well, how much did I originally start with? How much of my radioactive isotope do I have? Well, there's 40 kilograms present right now, so that's going to be my initial amount because I'm saying that this point in time is what my initial is. Well, my rate, I don't have. We know it decreases by 15%. So am I getting bigger or smaller? Good, we're going to get smaller. So we're going to get smaller by a negative 15%, but I want to turn that into a decimal. So what I do is I take that 15 divided by 100, which gives me negative 0.15. So now I have my negative 0.15. I'm going to take 1 minus that because everything's 100% to the t. I should have moved that over. What are you doing? Just being weird. So I have 40 times, well, 1 minus 0.15 is 0.85. So let's go ahead and find 6 days from now. So that means that my A is going to be A of 6. 40 times 0.85 to the 6. So 40 parenthesis 0.85 close parenthesis caret button 6. So in 6 days there's about 15.09 kilograms of my isotope. Well, what about 6 days ago? So what happened yesterday? So because we're going backwards, it's going to have negative 6. So I have 40 times 0.85 to the negative 6. So 40 parenthesis 0.85 close parenthesis caret negative 6. 6 days ago I had 106.06 kilograms worth of my radioactive isotope. Alright, next one. The value of a car decreases 20% each day. Complete the table. The value V of T of the car in dollars and its age T in T years. Give each value to the nearest hundredth. So if we're decreasing 20%, let's turn that rate into a percentage, or excuse me, that percentage into a decimal. So if I'm decreasing, I'm getting smaller, so it's going to be a negative sign. It's going to be negative 20%. And I take that 20 divided by 100, which gives me negative 0.2. Okay, so I have my rate. Do I have my initial value? Yeah, that's going to be my 10,000, because that's how much my car originally will cost. So my equation is 10,000, well, A of T is equal to 10,000 times 1 minus 0.2 to the T, not to the 6, to the T. Oh. So in purple, because I'm running out of space over there, my A of t is 10,000 times 0.8 to the t. So what we're going to do is we're going to go ahead and in my calculator, we're going to change our t's each time. So first one is 1. So what happens, how much is my car worth in 1 year? So I have 10,000 times 0.8 to the 1. Oops, and it helps to push enough zeros. There we go. So I should get 8,000. So my car should be worth $8,000 after 1 year. Next, I'm going to divide 10,000, or take times 10,000 times 0.8 to the second, because it's year 2. And I should get $6,400. I forgot this is a dollar amount. Year 3 should be 5,120. Year 4 should be 4,096, excuse me. And year 5 should be 3,276 and 80 cents. That's all I got for you. See you tomorrow.